All right, our next unit, we're going to take a look at the Pythagorean Theorem. And the theorem of Pythagoras is a well-known theorem, one of the most well-known theorems. It is also a very old theorem. Not only does it bear the name of Pythagoras in ancient Greek, but it was also known to the ancient Babylonians and to the ancient Egyptians. Most school students learn of it as a squared plus b squared equals c squared, and I'm sure you guys have heard that before. The actual statement of the theorem is more to do with the areas, and that's what we're going to take a look at today. So let's have a look at the statement of the theorem. So the theorem makes reference to a right-angled triangle, and the Pythagorean theorem only works with right-angled triangles, such as this right-angled triangle here. So right-angled triangle has a right angle, okay? The two sides next to the right angle are called the legs, and they're the shorter sides. And then the side opposite of the right angle is called the hypotenuse, and it's the longest side. So what the theorem says that the area of the square on the hypotenuse, so what that means, if I take the hypotenuse and I have this side length c, and I make a square out of it, okay? The area of this square is equal to the area of the squares made by both of the legs. They are the shorter two sides. So the theorem says that the area of the square on the hypotenuse is equal to the area, or is equal to the sum of the areas of the squares on the two shorter sides. So what you're going to do is, I'm going to show you here. You are going to take, I have some cutouts of the Pythagorean theorem. Get the area of one side, area of one leg, area of the other leg, and then the area of the square of the hypotenuse. And what you're going to do is you're going to cut out each of the squares. So I have the big square, the medium square, and the small square, right? So this is the square of the hypotenuse, and these are the squares of the two legs. And what you're going to do is you're going to try to cut these two squares, kind of cut them apart, and see if you can arrange them to fit on this larger square somehow. So how could I cut these and arrange them to kind of prove that this theorem works? Okay, so what I might want to try, I could try, I could put this down. I could try maybe cutting this up into strips and putting it on. All right, I can cut this into strips. Put on. You try whatever you think is going to work. I want you to try it with both. Okay, the larger triangle and then the smaller triangle. We're going to see that it works. It's going to work every single time. I want you guys to kind of show me that today. Once you're done with that, you can work on your review number 2. I think this review is going to be a little bit better for us. Give us more practice so that we're all ready for the test.